All right, welcome back again. So now we're going to go through the actual maximization. There should be another parenthesis here. So you're going to maximize the Lagrangian at every time step with respect to these three variables. So let's do it. How do you actually do this? You're going to consider s equals 0. So consider when s equals 0. So we'll call that L of 0 is going to be equal to beta to the 0 is just 0. So we'll get Ct over 1 minus sigma c to the 1 minus sigma c minus Lt to the 1 plus sigma L over 1 plus sigma L. Okay, minus lambda t because s equals 0. Ct plus kt minus 1 minus delta kt minus 1 to the pt. Excuse, there should be another parenthesis here. Minus rt kt minus 1 minus wt lt. Okay, that looks right. Now we sort of take stock. So here's where you kind of have to like understand where we're going. We need to maximize with respect to CT. So I see a CT is here. Get a different color. I see a CT here. I see a CT here. We need to maximize with respect to LT. I see an LT here. I see an LT here. We also need to maximize with respect to KT. And I see a KT here. Now, do we need to look at when script L equals 1? And the answer is yes, because we need to maximize with respect to KT. And you say, aha, look, I have a KT minus 1 here. When s equals 1, KT minus 1 plus s equals KT. And so there's a variable that we need to account for there. So we need to also look at when script L equals 1. Okay, so what happens when script L equals 1? First, we get a beta, because we have beta to the 1. Okay, and then we're going to have Ct plus 1 to the 1 minus sigma c over 1 minus sigma c minus Lt to the 1 plus sigma L over 1 plus sigma L minus, excuse me, t plus 1. Everything's always going to be t plus 1 now, because we're in s equals 1. Lambda t plus 1. Ct plus 1 plus kt plus 1 minus 1 minus delta kt plus s is 1 minus 1 is just kt. So again, here's where this is the whole reason why we had to step into this future time. Minus rt kt, again, because we have t minus 1 plus 1, minus wt plus 1. This is pt plus 1, this is rt plus 1. I'm sorry, you need to be very careful with these time indices. And lt plus 1. And we're going to close this parenthesis and then close this parenthesis. Okay, now we ask ourselves, do we need to consider when script L equals 2? Okay, so first off, is there anything here except for the kt that we need to worry about? The answer is no, because Ct plus 1 is not the same thing as Ct. When we take the derivative of this with respect to Ct, this term goes to 0. This term goes to 0. This term goes to 0. It's Ct plus 1. Okay, so Ct is not relevant at s equals 1. Same story for Lt. Lt is not relevant in the world when s equals 1. We have an Lt plus 1, but that will go to 0 when we take the derivative. Same thing here. We have this Lt plus 1, it will go to 0 when we take the derivative with respect to Lt, because they're not the same thing. The only thing that will remain is this Kt plus 1, this Kt and this Kt. But what about when s equals 2? We'll have Ct plus 2, Lt plus 2, lambda t plus 2. We'll have Kt plus 1 and Kt plus 2. Well, we don't have a Kt plus 1 or a Kt plus 2 here. We just have a Kt. So everything else in the future doesn't matter. We can stop here. These are the two components of our Lagrangian. So we need to take the derivative, and we can consider our problem. We can consider our problem script L. is being equal to script 0 plus script 1. Okay, this is the problem that we need to solve. That's kind of cut off, I apologize. Let me fix that. So we can simplify our thinking about this problem as being that our Lagrangian is equal to the Lagrangian 0 plus Lagrangian 1. Okay? And that comes from just this infinite sum, okay? LT. That LT is equal to the infinite sum over all of these Lagrangians. We investigated the Lagrangians one by one, and we found that, okay, at s equals 0, it really matters because we have a ton of variables that we care about. And at s equals 1, we have only one variable we care about. We have just this kt and this kt. And everything else is totally irrelevant to us. And so we reasoned that, we didn't reason, we noted that if we go to 2, 3, 4, 5, everything is irrelevant. So our problem will reduce from this infinite sum of s equals 0 to infinity to just a simple sum of 0 plus 1. Okay? So our true and honest final problem that we're going to look at is going to be, this is totally equivalent to max ct lt kt of L0 plus L1. Okay? That's where all this comes from. And yeah, that's all. So you just have to do this. So let's do that in the next video. Have a try, get your answers, and then you can come along and see what I do. So I'll see you there.